Hi, my name is Barbara Ray-Venter, and I am a search angel with DNA adoption and also help with teaching the autosomal DNA classes. This is a week presentation that I've given to a group of genealogists about AncestryDNA pedigree triangulation. And this is a supplement to Lesson 2 and sort of a preview of Lesson 3 for your autosomal DNA class. One of the things that has happened over the last few months is there has been an explosion in the number of people who are purchasing DNA testing kits from the various testing companies. As shown in this slide, the number of people who have bought test kits from AncestryDNA as of the 10th of November 2017 was approximately 6 million. That is followed in purple on this slide by 23andMe. And then down here in orange, we have a new kid on the block, MyHeritage. And then at the bottom here in red, FamilyTreeDNA. Also on this slide is the number of people who have uploaded their raw DNA files to GEDmatch. And that is shown in gray here. That's approximately 750,000 people have uploaded their kits to their raw DNA files to GEDmatch. In the period between Black Friday in November 2017 and the following Monday, so we are talking about 3 days, Ancestry reportedly sold an additional 1.7 million kits. So why am I telling you all this? Because it very much impacts how you can analyze your matches in your search to find your birth relatives. In December of 2017, I attended the I4GG conference in San Diego, and I went to a presentation by C.C. Moore on pedigree triangulation. Now, the gold standard for doing any kind of genomics research is DNA segment triangulation, which was pioneered by DNA adoption. So just as a reminder for those who've just started out on working on your genetic genealogy, DNA segment triangulation operates on the premise that if 2 or more people match with a third person on the same segment of DNA, and it is the and that is important, they all match with each other on that segment of DNA, then they have each inherited that segment of DNA from a common ancestor. Let's look at that at the chromosome level and see what exactly it is that you are doing. So let's say you're the son here on this graphic, and you have matched 2 other people as a second cousin match on this yellow segment of DNA here. Now you can see, if this is your tree, you can see that you inherited that yellow segment of DNA from your great-grandfather up here in the top row. So if you have 2 other people that you're matching with at a second cousin level, you know that you share great-grandparents. And if you're matching on that yellow segment of DNA, then they must each have the same great-grandfather that you have in their trees. So this can be used in a couple of different ways. Let's focus on if you're an adoptee and you're trying to find your birth father. So in this particular diagram, what you would do is you've now found these people who are second cousins. You've built out their trees. You see that you've got a most recent common ancestor who is that yellow great-grandfather. What you at that point do in DNA segment triangulation is you then build down from that great-grandfather to the time period when you would expect your father to have been born, and then either by targeted testing or just simply by the type of matches that you have, you can then identify the parent who has that same segment of yellow DNA, and there is your biofather. So we started out talking about how many people there are testing at AncestryDNA. Well, this is obviously by now by far the largest DNA database, and therefore it is really where you want to be if you were trying to find your biological parents. However, a key tool for DNA segment triangulation is chromosome information. And the problem with the AncestryDNA matches is that there is no chromosome information provided. So the solution to that problem is pedigree triangulation, which does not require chromosome information. Alternatively, if you had to do segment triangulation, what you would need to do, of course, is have your ancestry matches either upload their raw DNA data files from Ancestry to GEDmatch, or to transfer them to another company that does provide chromosome information, such as FamilyTreeDNA. So I'm going to discuss pedigree triangulation using a case that I actually have already solved. And this is the case that I mentioned. This is Lisa Jensen, the little girl who was abducted. And so what I'm going to do is I'm going to pretend that I don't know what the answer is to who her parents are, and just see if I can actually use pedigree triangulation to identify Lisa's parents. I'm skeptical that I can. I did obtain permission from Lisa to use her match information. It will be privatized, so names will be changed for the people that she's matching with in order to protect Lisa's privacy and also that of her relatives. So, as already mentioned, I do help with teaching the online classes, but one of the other things I do is I also answer the webmail that comes into our website. And in March of 2015, this email came in from a Deputy Peter Headley from the San Bernardino Sheriff's Department Crimes Against Children Detail. And what the deputy wanted to know is if the technique that we are teaching to adoptees to help them find their birth relatives, if that same technique could be used to identify a woman who does not know either who she is or where she was from. I told him yes, and I volunteered my time to work on this project with him. So really quickly, Lisa Jensen, this is not her real name, she was abducted when she was less than a year old. It actually turns out she was only 6 months old. In 1986, her abductor was living up in a trailer park up in Scotts Valley in Santa Cruz County in California. And there was another couple living in this trailer park whose daughter was having trouble conceiving. And she and her husband had indicated they would like to adopt Lisa. So Jensen, posing as Lisa's father, tells them that why don't they do a 3-week trial adoption, and if everything goes well, then he's amenable to them adopting Lisa. So of course they take Lisa, and when they come back 3 weeks later, he's long gone and changed his name. In 2002, he was arrested for murdering his common-law wife and burying her body in the basement of her home under 200 pounds of kitty litter. He died in prison, and he would never at any time reveal either who Lisa was or where she was from. And of course, Lisa, when she was abducted, was too young to know that information. So the research goal for the project is to identify Lisa's biological parents. The information that we have available is virtually nothing. We have no name. The name Lisa Jensen was just an alias that he had made up. There was no birth date. There was an estimate of about 1981 based on Lisa's dental development at the time she was recovered in 1986. There's no birthplace. In the time period around when Lisa was abducted, her abductor had quite literally been all over the US, from the East Coast to the West Coast, and up into Quebec, Canada. So we didn't even know whether Lisa was born in the US or Canada. There was no place of residence. The only known residence was the trailer park in Scotts Valley in Santa Cruz County, California. So pedigree triangulation involves creating genetic networks. And to create a genetic network, these are the things you need to do. You start out by looking at the ethnicity or admixture of the person who is the test taker. So here in Lisa's case, we're looking at what is her admixture according to Ancestry. And from that, we're going to calculate what her relatives must look like in terms of their ethnic background. So to give you an example, we know that we inherit about 25% of our DNA from each grandparent and 50% from each parent. So let's say you are told that your admixture is 25% Scandinavian, 25% Ashkenazi, and 50% UK. You can make a guesstimate that your grandparents are, maybe you have one that's Scandinavian, one that's Ashkenazi, and two that have UK ancestry. It's not cast in stone, it's just a way of looking at what you might be looking for in terms of your relatives when you are building your speculative trees. So now we're going to look at the shared matches that you have with your matches on Ancestry. And from that, you're going to create surname groups. And in the back of your mind as you're doing that, you're going to keep the idea of what you're looking for in the way of an admixture for each of your grandparents. So you're going to build speculative trees at that point, and then you're going to identify candidates for target testing. And then, of course, at some point, when you get the results of your target testing, you're going to add the person of unknown parentage to the speculative tree, that person being you if you're the adoptee looking for your birth parents. So just to see the difference in the landscape, as it were, back when I was working on this project back in March of 2015, and what it looks like now 3 years later, it's really quite dramatic. So these were Lisa's matches on Ancestry. She had one second cousin match with JRD. JRD had a very nice tree. And then she had one third cousin match, this NP Bois, with a little tiny tree, which I actually was able to build a speculative tree from. But unfortunately, this person was not interested in helping work on Lisa's project. All of her other matches were fourth cousin or more distant. So the first thing that we're going to do then is we're going to evaluate Lisa's admixture and then calculate what we think her grandparents are going to look like in terms of their admixture. So according to Ancestry, Lisa has approximately 65% UK ancestry. So we've got Great Britain, Ireland, Scotland, and Wales in that mix. She then also has another 30%, did I have that right? Yes, 30% Europe West, Europe South, and Iberian Peninsula. Iberian Peninsula being usually Portugal and Spain. And then she has a small amount of Scandinavian, which of course may be related to the Scotch-Irish ancestry. The other thing that Ancestry now tells you is they give you some other information about other groups of people that they see amongst your matches. So in Lisa's case, they identified two groups, which actually turned out to be related groups, the St. Lawrence River French settlers and the Boise, Quebec French settlers. And when I looked at the information that Ancestry provides about these groups, it turns out that actually the French settlers in the St. Lawrence Valley actually migrated to present-day Quebec, and then also after the French and Indian War, when French Canadians were not particularly welcome, and they migrated to other areas, we see that they migrated to places such as New England. And if we looked at migration of Lisa's matches, we in fact saw that they were migrating from areas such as Quebec and Three Rivers to Rhode Island, New Hampshire, and Massachusetts. So taking into account this information, let's look at who we think Lisa's grandparents are going to look like, or what we think they're going to look like. So we've got the 65% UK, which is obviously more than one parent. So that means that she's got two grandparents then with at least some UK ancestry. And then we have the 30%, which is the Europe West, South, and Iberian Peninsula, and more specifically identified as being French Canadian. So she has at least one grandparent then that's French Canadian, and possibly a couple of grandparents with at least some French Canadian ancestry. So the next step then is looking at shared matches of her matches to create surname groups. And then of course, as part of that, when we're looking at this, we want to find matches that have trees if at all possible. If they don't have trees, of course, you can always build a tree from scratch, but it's always nice if there's something that you can start with. So this is now then what Lisa's matches look like as of about 10 days ago. So if you recall, she had one second cousin match, that was JRD, and actually on this list, JRD has actually been demoted to being a third cousin. So she now has 6 new cousins that she did not have previously who are listed as second cousin matches. And actually the third cousin list is much more extensive than what I have here. So she's got a huge increase in the number of close relatives that she has who can be used to in this pedigree triangulation. Now I'm actually, just for the purposes of this study, I'm not going to cherry pick. All I'm going to do is I'm just going to take the first 4 matches, and then I'm going to take a look at who the shared matches are, who have trees, and what are the names in those trees. Are there any names that are in common that would suggest that we can perhaps build some trees that we can merge into a more complete speculative tree. So this is the first match that she has up there on the list. This is a big match. This is 477 centimorgans over 21 segments. This is a new match actually as of about 2 months ago. So one of the points here is that actually when we started working on Lisa's project, this kind of information was not given. They only told you that they were really excited about your match. They would say it was an exceptionally high confidence level. So this is new information now that you can get when you click on this little eye here, when you open up the view match. Sadly here we see that there's no tree, but it is a very big match, and it would I have sent an email to this person who of course has not responded. We're now going to look then at shared matches. And so here's the first shared match with CAS. So of course to get your shared matches, you just click on this box here in the middle. And actually Lisa has 50 shared matches with CAS. So this is obviously a hugely important match. Just you can suspect that from the size of the match. But the number of shared matches really underscores how important this match is. So Lois here, she does have a tree, but unfortunately this is a locked tree. So let's take a quick look at, in fact, where we do find trees, because you don't always find a tree listed here on this match page. So this is another of the shared matches. This is PM, and we see when we open up the view match to see how much matching DNA there is with this match, we also see a little pull down menu here inviting us to preview a tree. And so this little tree, I've blocked out part of the name, but this is a Mulcahy tree. And if we recall, one of our admixture groups is in fact Ireland, and Mulcahy sounds like it might be somebody who is Irish. Another place to find trees is to check the profile page for whoever the match is. So they might not have a tree listed on the main page. There may not be that nice little pull-down menu inviting you to preview a tree. But if you go to their profile page, you might find that they actually do have a public tree. And so here for this particular match, we see that in fact they do have a small public tree, which we can then obviously use for building our speculative tree. The other thing to keep in mind is sometimes the tree that is posted is not the only tree the person has. So here for James, this is now on the main page, we see this little tiny tree of 2 people. Well, yes, you might be able to build a speculative tree from these 2 people, depending on whether or not they have anything that's relatively unique about them. But if you go to James's profile page, you discover that James actually has another tree. So he'd posted the 2-person tree with his DNA, but he actually has another much larger tree that you can actually access. So what I chose to do in terms of then going through and looking at all these folks, I wrote down names that were in common amongst these trees. And again, I'm trying to do this without accessing my memory banks as to who Lisa's parents were identified as. These names are changed. So these are not the real names for Lisa's matches, but I've been consistent in terms of who we identified. So here we have up with CAS, we see some names, O'Hara, Martin, Cookland, and then Kirtland. Under RG, we have Dion and Graves, and then we have a couple more trees who have Graves in them. We then have JL. JL was kind of an interesting match, and this is something I've actually seen a couple of times, and you need to watch out for it. So JL, as you can see, is a fairly big match, 314 centimorgans over 16 segments. And when I looked at his tree, and I looked at his shared matches, so his shared matches showed the names Martin, Nichols, O'Hara, Nichols, and Nichols. But when I looked at his tree, he doesn't have any of those names in his tree. Now that didn't make any sense, because clearly if those are his shared matches, then he should also have those names in his tree. So I actually contacted him and said, is this tree that you have posted, is this your tree, or are you perhaps adopted? And I got a little email back from his girlfriend saying, no, it was her tree that she'd posted instead of his. But she did at the same time confirm that, yes, he did have Nichols and O'Hara in his tree. Excuse me, Nichols and Martin in his tree. And also Graves. So when you look at trees, think about whether or not they look like they're right, because sometimes people who are adopted will post a tree that is their adoptive family's tree, which is fine, except that for the DNA purposes, it's not particularly relevant. And so if you're trying to triangulate, you need to find out if this tree doesn't make any sense in terms of the other matches that you have for that person. It's a good idea to check with the person and find out if perhaps they have another tree, or if perhaps there's some reason why this tree is not making any sense. So having taken a look at this then, it looked like the place to start, since I didn't have a tree for CAS, and I didn't see a lot in terms of common names amongst the shared matches. What I did is I went with JL, because there were a number of trees which had shared names, and then of course we also had the folks down here under Sydney with those same names. So it offered some opportunities to build some trees and then perhaps to merge some trees, so I would get a better idea of relationships for who the biofather might be. The other comment here to make note of is we had identified 2 groups of people for our grandparents for Lisa. One of those was UK Irish, and we do in fact have some surnames that match with that, O'Hara and Nichols. And then we have the French Canadians, Dion and Graves. So we're going to be building a number of trees. So these are two little tools that will help you with building trees. And just as a caveat, whenever you're copying somebody else's tree, you need to verify the information before you actually use it, because there's no point in building a tree which has wrong people in it, because if you're trying to identify your birth relatives, if you have the wrong people in your tree, you're going to identify the wrong people as your birth relatives. That having been said, here are a couple of little Google Chrome extensions which copy only the direct line. So the Pedigree thief here copies the Anantafel file only for the direct line. And then DNA operatum is a little Google Chrome extension which will take that Anantafel file that the Pedigree thief has copied and turn it into a GEDCOM file that you can upload either to Ancestry or to your genealogy software. For those of you who are not familiar with Google Chrome extensions, if you have a Gmail account, you can log into your Gmail account and that will open up Google Chrome. You go all the way up here to the right and you click on, there are 3 vertical dots up here. You click on that, it will open this pull down menu and allow you to then click on Tools here. And then when you click on Tools, you get a second pull down menu which has extensions in it. You click on the extensions and it will take you to the extensions collection. And so this is, obviously this slide shows the extensions I already have. So if you're trying to add an extension, you would then go up here to the search window at the top here in the blue, and you would type in Pedigree thief or DNA operatum. And then once you click on that, it will then allow you to add the extension. And then a little icon will be added to the ribbon up here. And so the thief has a little green frog, and so the little green frog will be up there. He will not be green until you actually activate looking at a tree, and then he turns green. And the same thing with the Anantafel converter. It doesn't turn color until you're actually accessing it. Okay, so we're going to build some speculative trees and we're going to identify candidates for target testing. So let's take a look then. We're going to use the thief to copy some of these trees to give us a little bit of a leg up. You will still most likely need to build out these trees. As I said, they are only the direct line that is in here. And you should at least start at the bottom and go up, verifying the information up to the point where you're going to actually be looking for a most recent common ancestor, and make sure that that information is all correct before you spend any time building out this tree. So once you activate the Pedigree thief, you do need to have your tree in Pedigree format. If you try to click on it when it's not in Pedigree format, the thief will remind you that you need to put it in Pedigree format, which you do by clicking on the little icon up here, which shows the Pedigree format icon. So the Pedigree thief will then copy the Anantafel into this box. And then once that's been done, what you should do is go through, this happens to be a very small tree. What you want to do is go through and make sure that the first 21 people, that there is a name there, or if there's not a name, that you fill it in with unknown. So for this little tree, there were only 11 people in it. So what you need to do then is you type in 12 through 21 and then list the person as unknown. If you do not do that, then the Anantafel converter to the GEDCOM file will not run. So you're then going to save this tree. You're going to then export it to a plain text file. I happen to be working in Pages on a Mac, and so in Pages, it gives me an option of just taking the file and exporting it to plain text. So you'll need to use whatever on a PC. I believe it's Note that you can do this, and you can just then export to the plain text file, which is required by the Einentafel converter. You're then going to open the Einentafel converter. You're going to find the file that you just downloaded in plain text. If you have a male as the first person in your Einentafel, then you need to click this box here. You're going to give your tree a name, and then you're going to make the GEDCOM file. So going back here, then I just repeated this the number of times that I needed to copy all the trees that I wanted. So I had started out with the trees here under JL, and then went in and as I found common ancestors, I merged those trees. So I now had multiple people who were related to Lisa in my speculative tree. They're all in one tree. And then what I'm going to be doing is running kinship reports on that tree to find out how people are related to Lisa, and how her the bioparent should be related to her, and then identify that person. So the first thing you need to do in order to do that is then to calculate what the relationship of the match is to the test taker. So here that's Lisa. There's a couple of places that you can do that. There's a site called DNA Painter, and on DNA Painter it will calculate for you what the likely relationship is for a given number of segments, a given amount of matching DNA. Then DNA Adoption, we have our own little site for doing a relationship estimation. This is slightly more accurate than the DNA Painter because this one takes into account the number of matching segments as well as the total amount of matching DNA. So let's look at DNA Painter first. So DNA Painter, that CAS match that we have, that's the new match, what it will tell you is you plug in the 477 centimorgans. It will then tell you how sure it is that you have a particular match. It will also give you the less likely relationships for that same amount of matching DNA. It will also give you a visual of looking at what those matches look like, so you can see in terms of the range of these different relationships where your particular match fits, just to give you an idea of what that looks like. So the biggest match that we have with a tree is actually this person here, PS, where we have 240 centimorgans over 8 segments. So I think I have a slide out of order here. Well, no, let's go over this. So this was again then our closest match, CAS, and so this was when we use instead the estimator for DNA adoption. If you recall, there were several different relationships that the DNA Painter had indicated were possible. When we plug in the additional information that there were 21 matching segments, the DNA adoption estimator tells us there are actually only 2 likely relationships. One is a half first cousin, and one is a first cousin once removed. So in order to figure out who it is we're looking for in the way of a parent, we can go to a chart that looks like this. So if we have a first cousin once removed match, if we go to our chart here, we can see there are a couple of options for what the parent of a first cousin once removed would look like. In the one case up here, it would be a great uncle, since we're looking for a father. And down here, another option would be that it is a first cousin. So what we would then be looking for in our kinship reports when we do them is we would then look for people who are great uncles or people who are uncles in terms of potential people to target test. So then let's look at JL, who was, PS, who is the biggest match there that we saw who had a tree. And this was 240 centimorgans over 8 segments. The relationship estimator for DNA adoption tells us he's a second cousin, most likely. So in this case, we're looking at somebody whose bioparent then must be a first cousin once removed to PS. We would get that from that chart that I just showed you. So we run a kinship report for PS. We're looking for people who are first cousins once removed, since those are the people that we believe represent Lisa's bioparent. We come up with, so I'm looking for a male. So amongst all the first cousins once removed, there are 5 brothers, and then there's another person over here whose last name begins with R, who are all the males who are first cousins once removed to PS. So these are our candidates for Lisa's father. We now do the same thing with, this is JL. JL was that larger match who had not indicated, whose tree was not posted. His girlfriend's tree was posted instead. I happened to already have a tree for him from previously working on this case. So I did resurrect that tree. And so the DNA adoption estimator tells us that the most likely relationships here are a second cousin or a first cousin once removed. Going again to the relationship chart that I showed earlier, Lisa's bioparent then would be either a first cousin once removed or a first cousin to JL. So I go to the kinship report for JL, and I see that we again have the most likely relationship then as a first cousin once removed. This then matches what we had for PS, which is one of these 5 brothers, or this person over here whose last name begins with R. So we have some consistency in who we're identifying as being potential biofathers. We then have a third person so we can triangulate. This is GW. GW is a little more distant, so you're not going to have quite the same precision. This person, their match is 93 centimorgans over 4 segments. We have a much wider range of estimated relationships, anywhere from a third cousin once removed to a second cousin once removed, and then that would make the Lisa's bioparent a second cousin to a third cousin to GW. And in fact, when we ran the relationship report, it was actually a third cousin once removed that matched up with the other 2 estimated relationships, again pulling up these 5 brothers and one other man whose name starts with R. So what has transpired is that from the summary of shared match information for PS, we have a potential biofather for Lisa as one of the 5 Martin brothers, and then one man whose name starts with an R. Now I will note that I'm doing this, and at this point I don't have information actually as to who is Lisa's father and which is her maternal line. That would obviously come from analyzing more than the top 4 matches. What I am amazed at is that from just analyzing those top 4 matches, I was able to get this information. That the information as to which is the paternal line and which is the maternal line clearly would have come from analyzing more matches than the top 4. So let's return real quickly then to our big match, this new one of 477 centimorgans, and whether or not there's a way to help solve this match, to help solve the candidate for who is Lisa's biofather. Because right now we have 5 brothers and one other person who's a cousin, and how do we get to identifying which of those men is her father? So there is a probability calculator on the DNA Painter website, and I apologize that these colors are a little odd. I was working in Keynote, and in order to make this available to all of you, I had to export to PowerPoint, and unfortunately in that export process Some of the colors have been changed rather dramatically. In any event, so there is this link to the probability calculator on DNA Painter. So I don't have the information yet from CAS. I do hope that at some point I can make contact with that person and find out how they're related. So what I'm going to show you is using the probability calculator in two different ways. And Scott has up here this great-grandfather, Augustus. And so the choice is whether or not he's descended from Matilda or he's descended from Augustus. So what you do is you go in, you take the people who have tested. And so in this case, we've got these 6 people. Now, if we know what their relationship is, if he's descended from Matilda, then we have the relationships that they would have to him. And then we have the relationships if in fact he's descended from Augustus. And then what we do is we put in the amount of matching DNA. That's not going to change, that stays the same. And then the probability calculator on DNA Painter then gives you what the probabilities are for those various relationships, and then it gives you the overall relative probability or the odds of hypothesis 1, which is that Scott is descended from Matilda, versus hypothesis 2, that he's descended from Augustus. What are the relative odds? And then they come up in this case from being 1 to 0, because actually in the case of the second hypothesis, several of these were actually not at all likely. They were 0. In a second situation, I had now identified who I believed his father is. So we then have, again, 2 hypotheses. We have that the father is this person, Rudolph Jr., and then the other alternative is there were some other relatives that we were not able to find children for them. So we were not sure whether they had had children who could possibly be be Scott's father. And so I sort of bundled those all into a second hypothesis where Scott was a descendant of Rudolph Sr. Without specifying who the intermediate people were. And so again, in this case, I only had 2 people in my testing group. So I put them in here, what their relationship would be in those 2 different scenarios. Of course, the matching DNA to Scott stays the same, and then ran the odds on what they are, and we come up with a slightly better odds for it being Rudolph Jr. than a descendant of Rudolph Sr. And then just to show you the probability tool, so this then, we have the basic information here, and it then calculates the odds of it being being Rudolph Jr. versus some other person who was a descendant of Rudolph Sr. Another tool that can be very helpful if you if you do develop some information about different relatives, it allows you to paint out the chromosome information that's associated with different relatives. So this is what it looks like. This is just using my own data. So I have my various ancestors that I have that are the common ancestors for the people I'm matching with. So you can do this if you've got common ancestor information. You can just paint that out. You can copy and paste it from GEDmatch or from FamilyTreeDNA or wherever you have matching information. And then when you have somebody show up that you really can't figure out how they must be related, you can then overlay their information on top of yours. In this particular case, I have an Ian Fitzgerald has shown up as being a second cousin match. And I think I know most of my second cousins, so he's a bit of a surprise. He's even from New Zealand, which is where I'm from. And so I thought, okay, let me see how Ian Fitzgerald matches. And so here he is overlaid on what I know, and you can see what he's doing is he's matching in areas where I have no cousins who have tested. Well, I only have one ancestral line that I have no cousins tested in, and that's my paternal grandmother's paternal line. And so what I'm guessing is, since he's not matching with anybody that I've tested, that must be how this person is related to me. So I will be checking out that information. So it's a very handy way to sort of sort out, if you have a new match, how they might be related to some of the other people that you're looking at. So my conclusion from all of this is that, in fact, pedigree triangulation can be used to identify Lisa Jensen. And believe me, if I can identify Lisa, who has nothing but DNA as a starting point, then this technique should work for anybody. What it does take, obviously, is a number of matches who are fairly decent matches on Ancestry. You could also, of course, do this on any of the testing sites where you have available shared matching information. So there's, assuming that you have the right size and number of matches, there's no reason why you could not do this on FamilyTreeDNA using their in common with matches, or on 23andMe using their shared relatives, or on MyHeritage with their shared matches. You just need to have some fairly decent matches with some trees that allow you to get a good start on this, and it should work on any of those sites. Clearly, Ancestry probably has the advantage in that they have probably more matches for you, but that may not necessarily be true depending on what your background is. So just to put all of this in perspective, when I originally worked on the Lisa project 3 years ago, I recruited people from my local genealogy society, and also people who were Lisa's genetic cousins. We estimate that collectively we spent approximately 20,000 hours on sorting out who Lisa is and where she's from. This pedigree triangulation, identifying the potential paternal candidates for Lisa's biofather in January 2018. It took me about 10 hours. So these are some links to stories about Lisa and her identification. And again, I apologize that the colors on here are truly bizarre. That's something to do with the transformation process from Keynote to the PowerPoint. Hopefully you can read them. And then these are additional links to the Anantafel to GEDCOM converter, to the chromosome painter and relationship estimator, the DNA adoption relationship estimator, the Google Chrome extension Pedigree Thief, and then there's a webinar that I did for the Salt Lake City Genealogy Society on using DNA segment triangulation for identifying Lisa. Good luck with your research, and good luck with finding your family members.